Hi guys, welcome back. So this video we're gonna talk about one big lobule of the hepatocyte in in a bigger detail. So yeah, let me just explain this diagram first. So this is the hepatic artery, the branch of the hepatic arterioles. This is the branch of the hepatic portal vein, and this is actually the sinusoids, and this the blood that is actually coming from the both these supplies are actually gonna come from this periphery to the center of this vein known as the central vein. And there is a small space that is actually situated here right beneath the sinusoids. Okay, and this space is also known as a space of DC. Very important, very important, plays a very important role in many inflammations, many cases of inflammation of the liver, as well as cirrhosis. So we'll talk about that. That's why I said mainly disease of the liver is about the alteration in the histology of the liver. That's why we call it as liver histopathology. So this is actually the space of DC, and this one is actually the hepatocytes. Okay, this is a hepatic lobule, and this is the real hepatocytes, and these real hepatocytes are gonna be arranged in plates. So after sinusoids it's a space of DC, and then only we will have these hepatocytes which are arranged in cords or plates. Then in between these two hepatocytes we also have a space where bile is going to be secreted. So the blood is going to be secreted in this way, okay, from this periphery to the center, whereas the bile is going to be secreted from the center to the periphery. In between this not in between. I'll talk about how bile is secreted in another video, but then you just have to know that it moves from the center to the periphery right now. Okay, so all this thing I'll talk about later on. Okay, so by this bile will actually go on to this bile duct, as I've mentioned here, bile duct. Okay, and yeah, okay, so let's talk about this video, this slide right now. Okay, so what is really happening here is actually blood from the hepatic artery is actually being carried into the sinusoid. So it is actually, or we can also call it as, it is actually feeding the sinusoid, and the same also goes for the portal vein. So every sinusoid is supplied by the portal vein as well as a hepatic artery. So, a fun fact: 70 to 80% of the blood coming to hepatocyte is from portal vein, whereas 20 to 30% is coming from hepatic artery. So that's why that's why when the question in the exam comes, which one gives more blood supply to the hepatocytes, the answer is obviously portal vein, because they gives more percentage of blood supply to the hepatocytes, although they are just giving deoxygenated blood, but the question is asking blood supply. So um, you have to be very alert on those type of questions and all. So eventually both blood will actually mix in the sinusoids. Okay, so a bit from the oxygenated blood of the hepatic artery, as well as 70 to 80% of the deoxygenated blood from the portal vein, they are going to be mixed into the sinusoid. So the blood is actually moving from the periphery to the center, so they're actually moving from the periphery to the center, and this is also called as the centripetal blood flow in the sinusoid. So this is actually a special type of architectural arrangement. uh, why? Because there are hepatocytes arranged in plates. So um, sinusoids are very leaky, so whatever the blood is coming, the plasma is exposed to hepatocytes. So since the blood is coming from the periphery to the center and these sinusoids are actually leaky, so the plasma will actually be exposed to these hepatocytes. So they will actually move from the sinusoids to the space of DC, and eventually goes to the hepatocyte. So this space of DC is just acting as a platform for exchange of things to actually happen. Okay, so if toxins are coming, they will actually go into the hepatocytes, get detoxified, and if extra glucose is coming, it actually goes into the hepatocyte, convert to glycogen. And hepatocytes, and some of the hepatocytes, okay, let's say amino acid is actually coming, goes into the space of DC, goes into the hepatocytes, they'll actually do some things, and it will eventually be secreted back into this thing as a form of plasma protein, and this thing will eventually goes into the central vein, and eventually it will get into the blood. So space of DC, as you know, it is just outside the sinusoid. So whatever plasma is moving through sinusoid, it is in free exchange with this space of DC. So one phase of hepatocyte is facing space of DC for exchange. Okay, one phase, this phase is actually facing the hepatocytes for exchange. Okay, so one thing that you should know is for example, hepatocyte can synthesize albumin, secrete them into the space of DC, and from there it will eventually go to the sinusoid. So as I have mentioned before, space of DC is now acting as an exchange area between the blood flow which is passing through sinusoid from the periphery to the center of the lobule. So for example, another example is that hepatocytes also secrete bile. So this color, this orange color, not so orange, I think, yeah, this orange color. So hepatocytes, one side they are actually facing the space of DC, another side is actually facing the bile system. So bile is actually moving outside from the center to the periphery, and this is also known as centrifugal flow of bile. Okay, remember, from the periphery to center it is known as centripetal flow of blood. From the center to the periphery it is known as centrifugal flow of bile. So in summary, you must remember, for space of DC, plasma will go through the space, gets exchanged within the hepatocytes, and then enter the space of DC once again before entering the sinusoid. So it will come like this and eventually go like this and eventually enter the circulation. So but not all will actually enter the circulation. Some blood is not drained back. Okay, it's just same like the artery vein system. Okay, some of the blood will go into the this one, and some into the intracellular space, and 80% will actually get back into the vein. 20% of them will not get back into the vein, and how they are actually drained back into the circulation to the lymphatic vessel, and that is what is actually happening here too. So let's say uh, like 100% of this one actually goes to here, goes for exchange. Only like 80% will actually goes back into the sinusoids back after all this direction by these hepatocytes. Another 20% will eventually get back to the circulation once again, not through this sinusoid, but they will actually get to the circulation by lymphatic vessels. So as I have drawn here, lymphatic vessel. So this lymphatic vessel is also would be moving from uh, it would be having the same direction as the bile, centrifugal flow of lymphatic vessel, that is from this area, that is from the um, center to the periphery. And so bile will be collected at the bile duct at the periphery by bile duct. So and lymph will be collected by the lymphatic vessel at the periphery too. So we have two centripetal flow of blood and two centrifugal flow of other substance, that is the bile as well as the lymph. So how many channels are actually present at every corner of classic lobule? So basically there are four, but early histologists only found three, and that's why and they didn't actually recognize the lymphatics. So later on you got portal vein, hepatic artery as well as bile duct, and that's why they call them the portal triad. And later on only they found out that the lymphatic later on only they found out that there is something called as lymphatic vessel and call it as portal tetrad. So portal tetrad, I don't think so it will come out in exam. All you have to know is just portal triad, because the portal tetrad is actually a latest finding. So in every portal, but then for your knowledge, you have to remember this thing, that in every portal array we have portal vein and portal hepatic artery input, as well as two drainage system, that is the lymphatic as well as the bile duct. Okay, so next we can move on to the next this one. Okay, here we're going to talk about how the bile is actually going to be drained. So the central vein, okay, the central vein will actually take the blood from the center. Okay, this is actually the central vein. So it will actually take the blood from the center and drain into the sublobular vein. Okay, from the center it goes to the sublobular vein, and the sublobular vein will come together and make the hepatic vein. Sublobular vein will actually combine together in order to form hepatic vein, and hepatic vein will eventually drain into the inferior vena cava. So there are two input system for liver: hepatic input system as well as portal input system. And sinusoid drain the mixture of blood into the central vein, and the central vein come out and they drain into the sublobular vein, hepatic vein, and back to IVC, eventually emptying the blood into the right heart. So that is in summary uh, how the liver product is actually getting back to the circulation. And at the same time, the bile duct from every corner comes to left hepatic duct and right hepatic duct. Okay, as you see here, all the okay, bile duct at the corners of these lobules are actually gonna come into the left hepatic duct. This side is actually left hepatic duct, and this side is actually the right hepatic duct. As you see here, I have like made some labels here, and they will eventually fuse to form the common hepatic duct and goes to the cystic duct and be stored in the gallbladder. So common bile duct and pancreatic duct come together and opens at the duodenum. Okay, so okay, as you can see here, this common hepatic duct and cystic duct. Okay, one thing that you have to remember: right and left hepatic right sorry right and left hepatic duct, they will combine to form common hepatic duct and eventually be stored into the gallbladder through cystic duct. A cystic duct, common hepatic duct will actually combine together to form the common bile duct. Common bile duct as well as a pancreatic duct will actually open at uh, the duodenum, or to be precise, it's also known as the um, second part of the duodenum. There's also a sphincter called as the sphincter of Oddi, but it's another part of the video. It's an anatomical part of the pancreas, and not only bile, it will also secrete pancreatic juice into this part of the duodenum. So this is actually the whole structure of the biliary system. Okay. So in the next video, we're going to talk about a bit about the physiology of what those hepatocytes are going to do, and we're also going to be talking about the lobules of the liver, all the three lobules in more detail. Okay, thank you guys.